Okay, a while ago I did a video on the Suva equations, and I thought we could just look at a physics problem, which we could use them on. So this is a pretty typical problem. We have a football or something being kicked at 8 meters per second, right, as an initial velocity, at an angle of 30, and we want to work out the time it's in the air, the height, max height, stuff like that. So let's have a look at what we can work out. Firstly, I'd like to break this initial velocity up into a y component and an x component. We can work these out because we know that the y component will equal the sine of 30 times 8, which will equal 4. And the green will equal cosine of 30 times 8, which, let's just check that. Equals 7, basically. We'll round it to 7. So let's put those in. This is 7 meters per second, and this is 4 meters per second. Now, for the time that it's in the air, it's actually only dependent on the y component, if you think about it, because the only reason it falls is because of gravity acting on it, right? And gravity has no effect on the x part, so we can just think about the y part to figure out how long it's in the air, and we can just imagine it as a ball going vertically up at 4 meters per second, and asking how long that's in the air. That's actually going to be the exact same. So let's use one of the Suva equations. This one says the maximum velocity equals initial velocity plus acceleration times time. Okay, well, the maximum velocity is going to be 0, right? Right here. So, and what we're actually going to do is we're going to work out half of it and then times it by 2. We're going to work out the time up to the maximum height, and then we'll double it, which is why our maximum velocity is 0. So we have 0 equals initial velocity, 4, plus the acceleration is going to be negative 9.8 meters per second squared, right? Gravity. We would have a plus minus, so let's just put a minus. 9.8. And then our unsolved thing is t. So now all we need to do is solve for t. So let's move the negative 9.8t over. So we get 9.8 t equals 4. And then divide 4 by 9.8. So t equals 4 over 9.8. Let's just do that on our calculators. 4 divided by 9.8 is going to be this number here, so 0.41. We'll round it to 0.41. In fact, let's just round it to 0.5. Why not? Okay, just for the sake of simplicity. Don't forget, that's only half of its time, because it also needs to come down. So let's double that to get a time of 1. 1 second in the air. Let's put that at the top. T equals 1. Okay, let's work out the maximum height. Let's use the equation v squared equals u squared plus 2as. Let's rearrange it for s, so we can subtract u squared from both sides. So we get v squared minus u squared, and we can divide both sides by 2a, and that will equal s. Okay, let's plug in the numbers. So v squared, at the maximum height, it's up here, and that's going to be 0. So 0, 0 squared is 0, so that's fine. Minus u squared, our initial velocity squared, that's 4. Minus 4 squared, that's minus 16. Over 2 times the acceleration. Now our acceleration is negative 9.8 meters per second squared. So 2 times that would be negative 19.6. And that will equal s. And then we can just, these are both negative, so those cancel. So we get 16 divided by 19.6. So let's do that. 16 divided by 19.6. So we've got 0.82 if we round that. So let's say height equals 0.82 meters, or 82 centimeters. That might be better because then we don't have a decimal. Yeah, so you can see just by using those like pretty simple equations, we've worked out the maximum height the ball will be at and the time it'll take. Obviously this is ignoring air resistance, but yeah, they're quite simple equations to use and they can solve a little problem like this. So